Alright. Now the question is, what are we going to learn? And if anybody is getting tempted to say what, hold your horses, because I have already decided the topic, we'll talk about it. Tasvik, stay inside. And you can go only once you see your parents. Alright. So we are going to talk about interesting concepts today, where we'll talk about what are polynomials, monomials. Then we'll talk about how do we deal with adding, subtracting, multiplying, dividing polynomials. And then we'll also look at what are different degrees of polynomials. So it might sound like a very loaded class. It is not. We'll first touch upon the basic concepts of what is monomial versus polynomials. Then we'll do a recap of what we already know with respect to linear equations and quadratic equations. And then we'll go talk about how do we deal with the polynomials operations. Now, let's see. Yadav. Okay. So, just 1 second. Tasvik, stay back. Tasvik, stay back. Tasvik, you stay back. Stay back. Don't move when the car is moving. Now you go. All right. So, who all we have? One last time. Myra also has joined. Okay. Gitesh is here as well. All right. So let's start then. So we are going to talk about a lot of things in next 45, 50 minutes, not 50, maybe 55 minutes. Some of the things that we already know. We'll do a recap of that. And then we'll double click on some of the concepts that we want to learn today. So first of all, what is a polynomial? In the simplest form, okay, if you guys get excited to answer, hold your excitement, take a deep breath, Arav, no dancing class. Take a deep breath, answer with calmness. Nobody gets a prize for rushing through an answer. I would appreciate getting a calm answer than a rushed wrong answer. Let me repeat my question. I said, what do you mean by polynomial? And give me the lamest possible example, because right now I'm a 5-year-old kid. Let's see who explains that to me. What is a polynomial? Okay, Arab, you have 30 seconds.
A polynomial is an equation that has many types of coefficients or variables.
Okay.
For the Greek meaning, poly means many.
Okay. Alright. Anybody else? Tanu, Myra, Hiranya, Gitesh, anybody? No, Sundara. The question is, what is a polynomial? Dekshita. Any basic answer? No? Okay, yeah, Dekshita, tell me.
An expression that has a lot of terms.
Lot of terms, okay. Hey Gautam.
No.
Okay. Alright. So the question, so we have just started talking about polynomials. So the question that I'm asking all the kids is, what is the meaning of a polynomial? Tell me that as if I'm a 5-year-old. Explain me. Yeah, anybody?
It's an expression with more than 2 terms.
2 or more.
2 or more terms.
Yeah. So this is what I heard from you guys, and this is what I learned from you guys. So, what is an expression? When there is no outcome. If I say 4x plus 3y, this is an expression. If I put equal to 17, this becomes an equation. There is an outcome. So the basic difference between expression and equation is expression doesn't have an outcome.
Yeah.
it's as good as me teaching you guys, smiling all through, doing nothing. There is no outcome. If I come to the class, turn on the video and keep smiling with my nice expression for next 45 minutes, there is no outcome. You will not learn anything. There is nothing that you are getting out of it. Seeing me smile, it could be fun, but there is no outcome for you. There is no takeaway. So this is the expression. Now, when you say polynomial or what is the term? This is the expression. It could have something like this, or you could have 3x cubed plus 2y squared plus 3xy minus 19, and you can just go on. So these things separated by the operands, that's how you pronounce it, right? Plus, minus, what do you call it? Operands. Operands. The symbols for operation.
Oh, yeah.
So all these things that are separated by these operands are called terms. This is one term. So see, there is one operand here between these two. This is a separator. This guy is keeping them away or different from each other. Mostly it's plus or minus. You will not use multiplication as an operand. Okay?
Yeah.
Because in every term you will see 3 into x into y or 2 into y square or 3 into x cube, whatever it be. So you don't use multiplication or division as operands. It's only the plus or minus signs.
Yeah.
That decides how many terms you have. So now if you look at this expression, this is an expression, this is also an expression. What do you see here is this. This is an expression with two terms, one term and two terms. Why two terms? Because you have one operand. I know the pronunciation of this guy, okay? So, or one plus sign which is separating these two. This is called, this has two terms. Here you see one positive sign, one negative sign. So you have 1, 2, 3, 4, 4 terms. So any expression which has more than one term, if you look at this, 8x cubed, this is also an expression. This is only one term. So this is the only guy which is not a polynomial.
It's just a monomial.
This is called monomial, only one. So this is a polynomial because you have more than one term, which is two terms here. So this is the basic difference between monomial or polynomial, or what qualifies for being called a polynomial. That's the first thing that we wanted to understand. Okay, everybody clear what is a polynomial, right?
Yeah.
Any expression which has more than one term is a polynomial. And no question with respect to term understanding also. Right, Ritika, Arihan, Vasundhara? Smani clear? Now, so at least our understanding of polynomial is taken care. Now if I give you guys two situations, 4x minus 3y versus x squared plus 4x minus 18. What is the difference between this guy and this guy? Tell me two differences.
First one, that's a
Binomial.
Binomial, and the second one is a trinomial.
Trinomial, both are polynomial as well.
Yeah, and the first one has two different variables, the one and the other one.
Only one variable, okay. What is the other difference? Yep, Smriti.
Doesn't have an exponent, like, yeah.
Go ahead, don't be shy. No prize for being shy. Yes, Smriti, go ahead.
It doesn't, one of the, like the top equation, doesn't have an exponent.
Okay.
Oh yeah, I have one.
Yep.
Wait, no.
Okay. Anybody else? Hiranya, Thanu, Arihan, you guys cannot be quiet. You should talk. Teacher talks so much, you guys have to talk. I mean, obviously, not talk unnecessarily, but yeah, for a genuine reason. So, any other difference that you guys can think of? Advik, Deepchita. Yes, Arihan.
The one on the bottom, like x squared minus 4x minus 10.
18.
18.
Mm-hmm.
The 18 has an absolute value, I guess.
It has an absolute value of greater than, or greater than 0.
Okay. What else? By the time I come to your class, I am already exhausted because this is the third hour running when I am standing. This thing, do this Pushpa thing also, but that is not relevant for this class. Okay, Arav? Pushpa is one of the most illiterate person that I can think of from math perspective. Okay, that's how Pushpa is played in the movie also, right? Let's not talk about Pushpa. Come back to this one. So here, there's another difference that, okay, Advik, you want to say something. I'll let you complete.
So like the second expression has like a power.
This also has a power.
It's just
one.
Yeah.
Arav, what is your point of view? Quick.
The first one has two variables, so it needs a second equation, but the second one can already be solved for this one.
I'm not talking about equation at all. Let's not go to that dimension at all. So I was just trying to get your observation. Okay, everybody. Yeah, Gitesh, what is your observation?
They both are like different numbers.
Okay. So now hear my point of view. This has two terms. I will call this binomial. This has three terms. I can call this trinomial. At the same time, based on whatever we know, any expression which has more than one term qualifies for being called a polynomial. So this is a polynomial. This is also a polynomial. This another observation that you guys mentioned was this has two variables, x and y. This has only one variable. That's also a valid observation. Fourth observation is both have power. Here the maximum power is 1. Here the maximum power to the variable is 2.
So the degree is different.
The degree is different.
Yeah.
That would mean if I use this for plotting on a coordinate plane, this is a linear expression. This is a quadratic expression. When you have power more than 1, that is a quadratic expression. Now if I use this, I just put a 0 here, convert this to equation, and put a 0 here, convert this to equation. This will, or let's say if I put any number or something, whatever. Let's not complicate this. Let me not go to equation at all. I'm saying this is a linear expression because if I convert this to equation, it will draw a straight line for me. That's why it's called linear equation. This is a quadratic expression.
It would be a parabola.
So if I use this to plot, if I assume that this value is equal to y, this will plot a parabola for me. Whether this way, this way, this way, this way, that we will decode when we learn a little more about it. Okay? But if I'm talking about, so the basic observation for us is this is a linear expression, this is a quadratic expression. What it means in actual terms for us is linear expression always results into a straight line, quadratic expression results into a parabola when we plot in a coordinate plane. And again, if I ever try to convert this expression into an equation, let's say I'll say, okay, I'll put a y here and I'll put a y here. This becomes a linear equation, this becomes a quadratic equation for us. And then we can plot that to the normal way we always plot, right? You have x. See, when you have this equation, you know that, okay, fine. This is an agreement between x and y such that this will be the outcome. Here, this is an agreement between x and y, that x value and then this thing will be equal to y. And then I'll put different values of x and see what the corresponding value of y would be and then use that for plotting in a coordinate plane. Okay? So this one will draw a straight line for us, this one will draw a parabola for us. We'll come to that part also. Let's not rush through it and get little worried. And for you, Gautam, I know you were wanting to dig deeper into it, right? What I would do is I'll suggest you to join one of the SAT classes where we are learning parabola. Okay. So for this class, if I try explaining parabola, many of the kids will probably start getting stressed out. I will make you join from the SAT classes where we are learning this one so that you get the understanding in detail, and then you get ready for what you're wanting to do.
No, yeah, I get it. It's just like some problems.
Okay.
The method works for some problems and it doesn't work.
Right. So if just send me those questions, we'll talk through that, and I will send you the answer or approach for that. And if that doesn't help, we'll find out a way for this. Okay. All right. So we have just looked at linear expression and quantity expressions so far. Now let's look at some of the interesting standard polynomial rules or standard polynomials that all of us need to memorize or be very comfortable with. If I ever say find out this equal to what? Find out this equal to what? Find out this into this equal to what?
I know.
You know this.
Yeah.
Okay, so I'll quickly run through this, but my question to everybody in the class, anybody in the classroom who doesn't know what is the value of a minus b whole square, a plus b whole square versus, and a plus b into a minus b? This is nothing but, this is all about multiplying polynomials. If you look at this, this is one polynomial where you have two terms. You have another polynomial where also you have two terms. You are multiplying them. So multiplying polynomials is what we are trying to learn quickly. So a question for you all. If you have to find out a minus b whole square, a plus b whole square or a plus b into a minus b, how would you find it out? Okay. I know Gautam knows. Let me check on the screen. Anybody who can tell me how to find it out? Yeah, Dikshita.
Like what that's like how to solve it, but I like know what's like equals to.
Okay, tell me what it equals to first.
Or it's equals to a squared
First one?
minus b squared.
First one. How much is that?
I got a minus b, no, a squared plus
Plus?
b squared.
Okay.
Yeah.
Then?
I don't know the second one.
Okay. What is missing here?
You need a C.
A minus b whole square.
No, yeah, so you have to use the FOIL method.
Uh-huh.
That's what we learned in school. So you have to multiply the first two.
Uh-huh.
To
Tell me the answer first, then we'll figure out how
a
to.
squared minus 2ab plus b squared.
Minus 2ab. So that is what was missing, right? That's what I was trying to find out.
Oh yeah.
So a minus b whole square is a square plus b square minus 2ab. Now, who remembers what is the value of a plus b whole square? Okay, I'll come to Gautam for doing the final touches. Let's see. Anybody? Smarni, Hiranya, Vasundhara, Arihan. Anybody? Ritika? Yeah, Ritika.
Did you ask us to do the second? Did you ask us to do like the second?
A plus b whole square is how much?
Should I say the answer?
Yep, please.
A squared plus 2ab plus b squared.
Okay. Gautam, you are
Yeah.
agreeing to that? Okay, how about this one? A plus b into a minus b. Okay. Gautam is ready. Dikshita, tell me.
A squared minus b squared.
Okay. How about you, Arav?
I was thinking a plus.
Thinking, no thinking. No value for thinking. Have you done it? A notebook or you know it? They are the only two options. No thinking, no debating.
Oh, I know what.
Okay, tell me how much it is.
It has to be a plus b times a minus a plus b minus b.
We are going way too far. Okay. Anybody else? A plus b into a minus b. Just give me the answer. And I'm not forcing you guys to memorize this. I'm anyways going to decode this and explain you how it came into light. And that will become our base for multiplying polynomials. Because that's what we are trying to do. This is the basic part. And I'll also tell you guys how knowing this formula and application of this formula will help us deal with quantity equations as we come across it. Okay? Yeah. Alright. So a plus b into a minus b. What is the value of Gautam?
A squared minus b squared.
A square minus b square. So that is what Dikshita was also saying. So your answer was right. But I want you guys to sound more confident. When I'm talking math, I'm much more louder. I want you guys to be equally loud and point blank. Now look at this. A minus b whole square equal to a square plus b square minus 2ab. This is not the value just because an old man is saying so. There's a reason for it. A minus b whole square. Like you guys know, x square is nothing but x into x. Similarly, a minus b whole square is nothing but a minus b into a minus b. Okay? Now, this is a situation that we are dealing with, which is called multiplying polynomials. See, now look at this. There are two things in brackets. A minus b, and then another bracket is also having a minus b. When you are multiplying the polynomials, how does it work? You pick one. Let's say you are multiplying this thing with this guy. So you pick this guy, multiply with the whole thing. Then you pick this guy, multiply with the whole thing. That is how you break it down. So if you are trying to multiply a minus b into a minus b, what will that mean is you pick the first number, let's say a multiplied by a minus b. So this one is taken care. Then minus b multiplied by a minus b. Or you can go other way around also. So here, if you look at it, what did I do? Now we have to just break open these brackets. A into a becomes a square. A into minus b. So here you have nothing, meaning you have a plus. So plus into minus becomes minus. A into b is ab. Then you come to this guy. This is that. You multiply this guy with this guy, this guy with this guy. Done. Then you come to this guy. Minus b into a. So minus, nothing meaning plus. So minus b into a minus ba or ab. Same thing. 3 into 4 or 4 into 3. Both are same. Okay. Then minus b into minus b. So minus into minus becomes plus. B into b becomes b square. What did you get? A square. 1ab, another ab, both negative. So minus 2ab plus b square. Is this ringing the bell for everybody, or I'm talking to myself? Everybody clear? And don't have to be shy. If it's not clear, I would put all the possible effort for making it clear. So let's do one more thing, and then we'll go to what we are trying to do by doing all this.
Mr. Kumar,
Yes, sir.
can you explain it again?
Yes. So I'm picking up another one. That's what I had in my agenda also. A plus b whole square. Again, going back to the same old school. X square is nothing but x into x. Similarly, a plus b whole square means a plus b times a plus b. So far clear? I think. Yeah. Now, a plus b times a plus b. How do you break it open? What you can do is, you can say, okay, I'll multiply this guy with everything here. Or I'll multiply this guy with everything here. Any which way is fine. So I'm choosing that, okay, I'll use this guy as a base and multiply this guy with everything that I have here inside this bracket. Meaning, I'll pick this guy a times a plus b. So this guy is done. Then I have a plus. So basically this is like how you explode a bracket. How do you break a bracket open? Does it make sense?
Yeah.
Yeah.
But what if the power is negative? Then what happens?
So take one sip of water, let it flow down, then we'll take the second sip of water. Is that okay? So here I am not, see, my question to you guys was that I have a plus b whole square. What does it mean? Something square means something into the same thing. Now I am breaking it open. Up to this much, what is the confusion, you tell me? If there is a confusion, I would certainly want to answer that before I go to the next topic. Okay? Yes, Dikshita, you're saying something.
Can we add a and b and then square?
A and b, if you know the value of a and b, like a is 2 and b is 3, then you can add it. 2 plus 3 is 5, 2 plus 3 5, 5 into 5. That is okay. Right now our problem is we don't know what is the value of a and b. So these are variables so far. How do I add two variables? I don't know their answers yet. I don't know the values yet. So I will treat A as A, B as B. The time when we know the actual value, we will put that value and we will deal with it. Yeah? Yeah, Advik.
Can you tell me how you exploded the brackets again?
Okay, now look at this. If I have 1 plus 3 into 5, okay? What I can do, 1 plus 3 is 4 into 5. That's what it will become. Or I will say, no, I have a lot of time to waste. What I will do is 1 into 5 plus 3 into 5. This becomes 5 plus 15, 20. Same value. You're just
Split the first bracket.
You're just splitting that, okay? So this will help us. Now, so by doing this, so A plus B whole square, this is what we get. Now we are breaking open all the brackets because we don't love brackets. A into becomes A square. Now A into B becomes all plus, so it becomes AB. This one is done. Now here B into A becomes BA. B into A or A into B are the same thing, so I'll call it AB. Plus B into B becomes B square. Now you have one AB here, one AB here, both are plus, so you'll add them together. A square plus AB plus AB, meaning 2AB plus B square. Now, the basic thumb rule to remember in algebra is you never add apples to oranges or oranges to watermelon, neither watermelon to bananas. What do I mean by that? For me, A square, AB and B square are different. This guy is apple, this guy is pumpkin and this guy is tomato. They are all different for me. I will add, if I have to add A square B and AB square, for me this is apple and this is probably watermelon. They are different. I will only treat them same if the degrees are matching. Here the degree of A is 2 and here it's 1. There is no relationship. And that becomes your thumb rule. When you are dealing with algebra, when you are dealing with variables with different powers, that's why you would have seen when we broke this open, we only added this guy and this guy because they were identical. AB, AB. A to power 1, B to power 1, A to power 1, B to power 1. That's the only reason why we added them together. If I ever had AB, A square plus AB plus AB square plus B square, I would have said, okay, live like this, I don't care. Because they are different. These two are not same. So just be mindful and watchful of that when you are dealing with algebra. Is this not clear so far? Everybody? Now, so what we are going to learn next is multiplying polynomials. And then we'll come to dividing polynomials also. Okay? So, the basic standard polynomial forms we have seen so far is A plus B whole square equals to A square plus 2AB plus B square. A minus B whole square is nothing but A square minus 2AB plus B square. That's what we saw. These two we have seen. And third one is A plus B into A minus B equals A square minus B square. This one I have not proved and I will not prove. I want you guys to try this. Okay? You know it, how to do it?
Yeah, so I have a different way. Can you check if it's good? So basically what you do is, so A plus B times A minus B, you times the first, you times the both of the A's, so you get A squared, and then you times so then it's the out, you first times the in, like the first numbers of the two polynomials, and then you do the outer numbers of the two polynomials, so A times negative B, so you get minus AB, and then you do the inside, the inside of the first.
I would want to see the notebook, otherwise I'll forget. Yeah. Okay. So here, these are three standard polynomial formulas that we will keep encountering every day, no matter whether we like them or we hate them. Okay, so that's why we just looked at how this formula came into existence. Now the next thing we would want to do is multiplying polynomials, and we have literally seen it just now. If somebody says multiply x plus y minus z with 3x minus 2y plus 18. If you have to multiply this, who can multiply this without freaking out? Okay. So a plus b into a minus b you can leave for now. This is the question. I want you guys to give it a shot. And Arab, if you are raising your hand without understanding the question, this will not be very productive. If you have a question, go ahead. Because I don't think anybody would have solved it by now. Yeah, Arab, go ahead.
Never mind.
Okay. I'm reading the question again. X plus y minus z multiplied by 3x minus 2y plus 18. I want you guys to give it a shot in a more playful way than being stressed out by seeing the size of the problem. Can I assume that Nihan, Myra, Ritika, Arihan, Thanu, everybody is trying? Okay. Yeah, Dikshita, tell me.
I got 18C, sir.
18C? Already? This is not an easy problem, I can guarantee that. I mean, not as easy as it is an easy problem, but it will take time. Arav, tell me, what is your starting point?
So how about got to the solving part is x plus y minus z.
I want the answer.
Oh.
See, look at how dirty my hands are. I want your hands to get dirty as well while doing math.
Mr. Kumar,
Yep.
you know when it says 3x into y? Is it a subtraction or addition? Because it's getting covered by the lines.
Okay, let me read it and just make sure that you guys are hearing it clear. X plus y minus z in bracket multiplied by 3x minus 2y plus 18. Okay? Yeah, Dikshita.
I got 3x squared minus 2y squared minus 18z.
3x squared minus 2y squared minus 18z.
Yes, sir.
This is not that quick. Okay. Yeah. Let's see how everybody is doing it. And trust me, you guys will laugh at it, or you guys will say that, oh, this was so easy, I probably overthought about it. My methods are very orthodox, very, very orthodox, the old school way, as old as I am. So, okay, let me not disclose the cards. Dikshita, even if you see, the advantage with kids who have already done it and have given me the answer, look at your answer and see what else could be missing. Because if you guys remember, when I was doing a plus b into a plus b whole square, what did I do? I said, okay, fine, I'll take this as a base, multiply every element with this thing. So like 1 plus 3 into 5 became what? 1 into 5 plus 3 into 5. Same concept will apply here as well. Yes, Dikshita, you're saying something.
Did you put 18 square or z at last?
Here is the
No,
z.
the answer.
18. I put 18z. 18 into z. That's what I heard. Yeah, Ritika.
I got an answer, but it's like really long, so I'm not.
That's okay. Every answer is worth giving the respect. Tell me what the answer is.
Okay, so it was 3x squared plus xy plus 18x minus 2y squared plus 18y minus 3xz plus 2yz minus 18z. But I need to check it again because I don't know that.
That's okay. Minus 18z, right?
Yeah.
So this is something that I would certainly praise you for, because this clearly tells me that yes, Ritika has certainly attempted solving the problem. Whether there's some mistake or not, that will anyways figure out, okay? And that you will also figure out while doing the review. So I'll let you do review. Let me see what the response from other kids are. Yes, Advik.
I'm not sure, but like I have 3x squared minus 2yx plus 18x
Okay.
plus 3xy
Okay.
minus 2y squared
Okay.
plus 18y
Okay.
minus 3xz
Okay.
plus 2yz minus 18z.
Okay. Okay. Yeah, Gitesh. You also got a long answer like what Ritika and Advik said?
I got 4x minus
4x minus?
3y plus 18 minus z.
Okay. Alright. Let's see what Arav got.
I got 2y plus 38xy minus 40y.
Okay. So this is actually an opportunity for me to teach it. Because I'm seeing all diverse answers. Yes, Gautam.
I'm just checking out.
Okay.
Okay, I got it.
I'll
I got
just look at this one.
this is
Yeah, I'm looking at this one. Okay.
this 18.
Okay. Alright. So now, yeah, Yadikshita, anything to add?
Yeah, can I change my answer?
Mm-hmm.
So I got 3x squared minus 2yx minus 18x plus 3xy minus 2y squared minus 18z plus 3x plus 2yz plus 18z.
I don't care. I am sure you don't want to hear that from me. Okay, so see, when I said I don't care, I was actually caring when I was talking about it. Meaning, see, what is my takeaway as a teacher? Now, Dikshita herself got her answer corrected. Dikshita will sound more confident. Dikshita will think that, okay, what I was doing before, there was an opportunity to correct. Correct? That's what makes me happy as a teacher. So, regardless of what statement I say, I get happier when I see you guys putting the effort in the right direction. Now, that's why I had all praise for Ritika. As soon as I saw her saying a lot of things one after another, I don't know whether this was right or not, but at least I can guarantee that she was trying to solve the problem. Same thing with Gautam also. When I saw you doing it, I was confident, okay, if you try it, get your hands dirty, you'll figure out how to get it right. So that's why I don't praise anybody if you guys quickly rush for an answer and tell me some answer. I want you guys to always put the effort for doing it. Now, all the other kids who have not done it or who are still doing it, let me guide you guys to start doing math like a story. You have to do math like a story, okay? You might be right with what you did, Gautam, but what is missing there is story. Because story tells you to figure out in which chapter you went wrong. And now you have done this, you have done review of it also. It's very possible that you are correct. I'm not denying that. But in the examination like scenario, when you have 50 problems to solve and you got only 10 minutes to review, and you know that okay, there are probably 5 to 6 questions which you have marked that okay, this is where I want to come back. But if you have not written the story, it will be very difficult for you when you are grappling with time to come back and figure out okay, what was the calculation behind. So math is more like an extension of English, that's what I call it. Now look at what I'm doing, okay, and tell me if this doesn't make sense to anybody. Now, first of all, thanks to everybody for attempting this problem. This problem is not coming from any notebook, I just made it up on the fly. Now look at this. I have 2 polynomials to be multiplied. This polynomial has 3 variables, this has 2 variables. I don't really have to worry about it. I have a very basic method for breaking open the brackets when I'm dealing with polynomials. What it means, same scenario, 1 plus 3 into 5 is nothing but 1 into 5 plus 3 into 5. That's what we'll do here also. Meaning, I will, let's say, guys, go, be on mute. Be on mute. Now, no opportunity for anybody to talk when I'm doing math. Now, this is what I'm taking as a base. I can take this also as a base, not a problem. Okay? I'm taking this as a base and I'll multiply every element with this guy. So, my story becomes like this. This means this equals x times 3x minus 2y plus 18. So, x is done. Plus y times 3x minus 2y plus 18 minus z times 3x minus 2y plus 18. And this doesn't take time. Whatever is going on in my mind, I'm just writing it down. And then I have to break open every bracket and then add the similar things. Meaning add bananas with bananas, apples with apples, oranges with oranges. That's what I look at. Now look at this. X into this becomes 3x squared. X into minus 2y becomes minus 2xy. 2x into y. X into 18 becomes 18x. This bracket is done. Then I'm coming to this guy. Y into 3x. So 3x into y. 3xy. Y into minus 2y becomes y into y. Here I have a plus, here I have a minus. So becomes minus 2y squared. Y into 18 gives me 18y. Now this one is also done. Then I'm coming to this guy. Minus z into 3x. So minus 3xz. Minus into minus becomes plus. Z into 2y. So 2yz. Minus z into 18. Minus 18z. This is what I have. Now I'll start my hunt. Easter is coming, right? You guys will all go egg hunting. That's what I want to do now. I have x squared. Do I have anything matching with x squared? No. I'll put 3x squared. This is done. Keep marking it so that you are not going to miss anything. Now I have xy here, I have xy here, and that's it. Right? So here I have minus 2xy, here I have plus 3xy. So I have minus 2 bananas plus 3 bananas equals 1 positive, but one banana, that is xy. So these two are also done. Now I'm going to x thing. I have 18x, 18y, 18z. Okay, but there's nothing with x. So I will write 18x. This is done plus 18y. This is done. Then minus 18z. This is also done. Okay. Now what do I have? I have minus 2y squared. Is there anything common to that? No. I will just write it down. This is also done. Then I have minus 3xz. There is nothing matching or that I can manipulate with. So minus 3xz. This is also done. Plus 2yz. Did I do anything fancy? No. What did I do? I converted my math into a story. That's it. Yes, Advik.
So what if I got like the long answer and I didn't simplify it?
What is that?
What if I got the long way and I didn't simplify it? That's fine.
That's fine.
Oh,
See,
I got it correct.
You got it correct?
Yeah.
Okay. So basically what I'm saying is, here, the only advantage with this approach, I know, see, again, that's where you'll do your work quickly, obviously, because there's no serious thoughts involved here. You will just do it quickly, and then this tells you that okay, fine. If you have to review it in future, right? Let's say after doing the exam, towards the end of the exam, it's okay, fine. I have this. I split it correctly. This part looks okay. Then this one I broke open. That's okay. This one looks okay. This one looks okay. Fine. Then nothing matching here. This one got together. Okay. So you can probably put some asterisk also. That helps you with your quick review. Okay, this two only got together. Everything else remains as yeah. I'm good. So this review, the extra 1 minute that you spent while writing the story, the way your brain was processing, that helps you do your review in less than 5-10 seconds. Yes.
I also did something different. For to solve it. I multiplied each variable by everything like one at a time. So by so it says x plus y minus z. So first I did x times 3x, and then I did y times 3x, and then I did minus z times 3x, and then I kept doing that, and
that's also
works.
fine. Yeah. So see, you did a reverse of that. See, you said x, so this is as good as you are taking this as a base and then multiplying these elements. It's the same thing basically. So you always have the option. You can say, okay, if I have to multiply a into b, see, life remains very simple, okay, if you keep it simple. If you have a into b, it is as good as b into a. So it doesn't bother us. You say, okay, fine, I love b. Okay, because my name starts with a b. It's okay. I'll do b into a. Yeah? Advik and Arav will say, no, I love a. Because their name starts with a. Wonderful, no harm. You put a first. That's okay. There's no z here, that's why Gautam is not able to do that. No, that's okay. You can have your preference, but your underlying concept, the fundamentals don't change. Make sense? Everybody with me? Is everybody with me?
Yes.
Everybody. Okay. Now,
Yes.
so Sanvita joined a little late. So let me ask, Sanvita, are you with me, beta?
Yeah.
Aditya, have you been able to follow what I've been doing?
Yeah.
Okay.
Sir, I have to leave in 2 minutes.
Okay, no, that's fine. I also want to leave as soon as I can, but I still have to be here for 11 more minutes. Alright, so coming back to this one. Now, whatever we have done here, I can shamelessly say that I have not taught you guys anything. Okay? I just told you stories. And story has a lot of weight in it because stories are the things that last with us for the longest time. I'm not sure if you guys have heard stories from your grandparents or not, or got a chance to do so or not. But whatever story you would have heard when you were a baby or toddler, some of those stories will stick with you for a much longer time. I mean, regardless whether you are hearing it from grandparents or from your parents, but stories stay longer with you. So that's what we are doing here. When we are doing the math, we are just writing it like, okay, the way our brain is processing, that's how we are putting it. Because trust me, when you are in an exam-like scenario, you'll be hard pressed for time, and you'll be under a little bit of stress. Oh, okay, I have to finish it quickly, and that stress will probably make you go wrong. So that is why you have to keep things as simple as you can, so that by the time you come to review or revise, you are all prepared. Now, let me give you guys interesting problem that I want you to solve immediately. X squared minus 25 divided by x plus 5. Who can divide it in 2 minutes? This is a polynomial. This is also a polynomial. We are talking about dividing polynomial. One polynomial by another one. Yes, Monday.
Can I just give the answer? Do I need to explain?
Yep. Now give the answer first.
Okay. I got x minus 5.
X minus 5. How about you?
Also, I got x
Same. Okay. So, Arav, what did you get? X minus 5.
I got x minus 5.
X minus 5. I saw your dance first before I heard your answer. Okay. How about you, Dikshita?
Sir, x
Yeah.
minus 5.
Advik, same.
X minus 1.
Okay. So here, why I'm giving this kind of a stupid easy problem? because I'm just trying to relate this with what we learned just now. When we looked at the standard polynomial expressions, where we talked about a plus b whole square, we talked about a minus b whole square, and we talked about a square minus b square equals a plus b into a minus b. This was a classic example. When we looked at this one, the first thing that came to your mind was, okay, this is a x square minus 25. 25 is nothing but 5 square. So x square minus 5 square by x plus 5. And here a square minus b square gives me a plus b. So here x is a, 5 is b. So it becomes x plus 5 into x minus 5. Oh, then I can do tic-tac-toe. Yep, this is my answer. This is exactly what you guys did. So, and this was just it's like touching the tip of the iceberg. That's what we did just now. We'll talk more about it, but for everybody in the class, okay? Aditya, Sundara, Arihan, Tanu, you guys have not been talking. Sanvita is quiet as well. Hiranya has not said anything so far. So I'm assuming that everybody is able to follow me. Gitesh, did you see the difference between the different answers we got and what was the reason for the difference? Were you able to break it down?
Yeah.
Okay. So no matter whether it's a Sunday or a Monday or Saturday, regardless of the days of the week, if I am multiplying this with, okay, my approach will not change, okay, regardless of the day of the week. I will pick this as a base, multiply every element one by one, or I'll pick this as a base, multiply every element one by one. That will be my only way to go. It is tempting when you look at the problem like this. Okay, A here, A here. The teacher has told me that I will only deal with apples with apples. Okay, so these two apples go together, these two bananas go together, these two watermelons go together. No, that is not the case. Okay, anyway, these two are not watermelons. This is watermelon and this is lychee. Okay, so don't get tempted with that. Okay, because if you have brackets to open, yeah, it's like a barricade. You have to explode it with a small RDX and then you deal with it. If you don't explode it correctly, it can hurt you. Okay? So, I'm not trying to teach you guys how to deal with explosives, but I'm saying that you still have to break open your brackets. Okay? In the right way. So, let's do a quick summary of what we have learned so far, so that when we go to the next class, when we talk about dealing with multiplication or division of polynomials and when we solve few problems, you'll be able to relate. We looked at the standard polynomial formulas where we talked about a plus b whole square, a minus b whole square, a square minus b square. And again, it is not because I told you guys to memorize it, we just saw it happening the same way any polynomial multiplication would happen. That is one. Then we also looked at basic definition and understanding of polynomials. Then we looked at the basic difference between polynomials, what is a regular linear polynomial versus a quadratic polynomials. We have not decoded or talked about the quadratic polynomials or parabolas. We just again touched the surface to understand the difference between the two. And then we just did a sample example of dividing a polynomial by another polynomial. And everything will relate back to the three formulas that I put in the corner. That will be a starting point. Okay, I'm not saying that everything will be like that, but that will be a starting point. Let's say tomorrow if I say, I have a polynomial like x plus 9 divided by x plus 3. Can you guys divide this now? This is not relating to any of the two formulas that I was talking about. If you have to divide this, the dance will not help. Look at the math part of it. I am giving the question and Arav is doing the breakdance. Michael Jackson is no more. Yep. Tell me, how would you approach this? And again, I'm just trying to give you guys an approach, that's it.
I forgot. I thought about it and I forgot.
Yeah, Arav, tell me. What does Michael Jackson say?
So I divided x by x because if you like divide 1 by 1, you get the same results. And I did 9 divided by 3 and I got 3, so my final answer will be x plus 3.
Because, no, it won't be.
No, you not do that. You not do it that way. That's why I was saying Michael Jackson is irrelevant when it comes to math. So when you started your move with the math question, I knew that we are going in the wrong direction. Yes, Advik.
So what I would do first is I would do tic-tac-toe and like take away the x since like we're dividing it. And then I would be left with 9 over 3. And I know that 3 times 3 equals 9. So my final answer would be 3.
No, that is not right either. Anybody else? Sarvita had raised hand, I believe.
No, I didn't raise
You
my
do not. You don't want to be on the spot. Okay. Vasundhara, Tritika, any thoughts? Barney, Arihan?
I mean, I was about to say the same thing that Arav said.
Okay, no. Because the start was not right. So, okay, now look at this. When you're dealing with polynomials, there are a couple of basic formulas, the concept that you have to keep in mind. Let's say if I say 4x squared plus y plus 3xy. First thing is these two are not same. A very stupid example. If I call this as, let's say, potato, this is eggplant probably. There is no relationship between these guys. They will be same or worthy of being added or subtracted together only if you have a matching power for all the variables. This is the only reason, only possibility, only chance when you can think of dealing with them together. Here also you have power x, power to x is 2, here also you have matching power and y also has matching power. That's how you say, okay, this is apple, this is also apple, so 4 plus 3, 7 apples. This is one thumb rule. Second thumb rule is, when you are dealing with situation like this, it is as good as this is apple, this is oranges. They are not same. You cannot deal with, if I ever taught you guys tic-tac-toe, that tic-tac-toe was only for situation like this.
When there were two different sets of polynomials? Or is it?
The tic-tac-toe was only when you are dealing with only multiplications. Don't use tic-tac-toe when you have a plus or minus sign in the numerator denominator. Here the tic-tac-toe is this, 8 and 8 gone. That's it. But if you are applying tic-tac-toe here, you are going in the wrong direction. So here, when you have plus or minus sign in the numerator denominator, you will not be able to do any tic-tac-toe or any calculation right now. What you can do, x plus 3 will be only equal to x plus 3, nothing else. What it means is x plus 9, I can say x plus 3 plus 6. This still is okay.
Yeah, then you can use tic-tac.
Then you will say, okay, then that means it's like a plus b by c equals a by c plus b by c. If you guys remember how you do fraction addition, right? What you do, you take LCM of the denominators. Here both are same, so LCM is this, so it becomes a plus b. Correct? Same thing applies here also. A plus b by c equals to a by c plus b by c. That's how you break it. Gitesh is probably getting stressed out. What this man is telling. Are you guys able to follow me so far?
Yeah.
Is everybody with me?
Wait, the answer be 6, because just use the...
Okay, no, not yet. So there is one, I'm a big time hater. I make a lot of hate speeches. And That's where many times I say I don't care about the answer. Because when we get biased for the answer, I mean, again, I don't mean to be a hater. I mean, I'm not a hater by any chance. I'm saying I make statements like, okay, I don't care about the answer. Because I have a feeling that if I think too much about the answer, I'll get biased. So that's why I'm not rushing for it. Now, come back to the situation. A plus B by C equals A by C plus B by C. We'll keep this concept in mind. Yeah? Now, here what do I have? If I treat this as A, this is my B. So A by C plus B by C. That's what it will become. So x plus 3 by x plus 3 plus 6 divided by x plus 3. That's why I was stopping here actually. So this, now you can do tic-tac-toe. You have numerator and denominator being same. So this becomes 1 plus 6 by x plus 3. Make sense?
Yeah.
Does it make sense to everybody except me?
Yeah, but why can't you do the tic-tac-toe when it was x plus 3 plus 6?
No, because I still have plus sign here. I see if I do tic-tac-toe here, this and this, then this is not right. This defies my basic concept. A plus B by C is nothing but A by C plus B by C. Or even look at a mathematical example here. If I have 5 plus 3 by 4, or let's say by 5. What does it mean? This is 5 plus 3 is 8 by 5. What will be my value? 1.6. Right?
Oh, is it
Now,
because it's not multiplying, it's just adding?
it's just adding, right?
Oh.
So now look at this mathematically also. 5 plus 3 by 5 is nothing but 5 by 5 plus 3 by 5. This gives you a 1, this gives you 0.6. That's what it will add to. Yeah? Did everybody understand what I was doing? Smarni, Ritika, Sanvita, Hiranya, Nihan, everybody? Arihan?
Can you
Adit?
repeat it again?
I'm sorry?
Can you repeat it again?
Okay, so we are going to do a little more practice tomorrow, okay? Because these are the topics that has no weight in it, okay? These are not difficult topics by itself, but it is very relevant and it requires a lot of practice. If you don't do practice, then the chances of going wrong is more. Let's say if I say x plus 15 now, I change the question, okay? By x plus 5. I cannot do tic-tac-toe this and this. No, that will be a crime, not a mistake. Okay? So, what I have to do is, I will break into two smaller pieces. X plus 5 plus 10. Now this looks something that I can do about. So this becomes, this is like A plus B by C is nothing but A by C plus B by C. Tomorrow if you have A plus B plus C by C, then it becomes A by C plus B by C plus C by C. Okay? So here you have A plus B and this is your A. So now you can break it, saying A plus x plus 5 by x plus 5. These two things are similar. At least you will get one simple value plus 10 by these two you can do tic-tac-toe together, not x by x and 5 by 5. You are doing x plus 5 by x plus 5. Okay? Is it making sense? Yep.
Then what would be the answer? Would it be 10 over x plus 5?
Yeah. No, it will be x by 5 by x by 5. 1 by 1 is 1. 2 by 2 is 1. 5 by 5 is 1. X plus 5 by x plus 5 is 1.
No, yeah, but you put 10 by x by 5, so...
Yeah, so it will be 1 plus 10 by x plus 5.
Oh,
I'm saying don't ignore this part. You'll see that oh, this is gone. This is not gone. This is still there as 1.
okay.
Yeah? Make sense? Enjoy. Or a domain expression.
Yeah.
And I'm trying to make life easier. You guys are trying to make it complicated. Don't do that.
It's called domain extension.
Okay.
You should just
let it be called Domino's expression, let it be Pizza Hut expression. I don't really care. As long as my calculation is fine, I would not want to worry about the name part of it. Okay? But regardless, I mean, you guys might have to remember it. What I'm saying is, make sure that you don't move away from the basics. As long as the basics, your approach remains the same. These are the things that I learned when I was your age, right? I mean, that's when I would have started. As long as you stick to the basics, no matter how much distraction you are getting from ChatGPT, this will still remain. Okay? If you ask ChatGPT to do this, they'll only do chat, no GPT. Alright? Take care, have fun. Otherwise, I will keep on cracking dad jokes. Alright? Are you okay? Are you okay?
Yeah,
Yeah.
it's just, I'm fine. I didn't get hurt. It just,
No, it's okay.
the bed's just
Alright, bye bye. Yeah, no, that happens. It is. Wait. You tell me how, right?
Yeah,
That is very
I'm
important.
feeling fine.